Hello everyone, my name is Juan Varga. I study electrical mechanical engineering. My topic is about automation in high-speed railroad transportation. Definition: Hangar control is adequate before long-speed railroads that are resident district that is handling virtually no damage inside in. But for either right train control that is automated incorporated in order to make sure safety and reliability and handle control is long and inaccurate for high-speed operation.
After more than 1 decade's development, China has entered the era of intelligent operation of high-speed railways. Through painstaking research, CRSC has complemented its proven and reliable CTCS-3 train control system with ATO and other functions to develop its ATO system for high-speed railways with high automation and intelligence, which is applicable to high-speed railways with a running speed of more than 300 kilometers per hour and a minimum headway of 3 minutes. This system has been demonstrated on intercity railways of the Pearl River Delta region, i.e. Dongguan-Huizhou line and Guangzhou-Dongguan-Shenzhen line under the speed condition of 200 kilometers per hour, and will be applied to high-speed railways with a running speed of more than 300 kilometers per hour. The ATO system for high-speed railways includes onboard equipment and wayside equipment. The onboard equipment integrates the onboard ATP equipment of the CTCS-3 system with the ATO unit, GPRS radio, and relevant auxiliary equipment, while the wayside equipment integrates the TSRS, CTC, TCC, and other equipment with ATO-related functions, adding precise positioning responder. According to the train operation requirements, the CTC equipment transmits the train routes to the RBC equipment via the CBI equipment, and the RBC equipment transmits the movement authorities to the onboard ATP equipment. The CTC equipment transmits the train operation plans to the onboard ATO equipment via the TSRS equipment. The onboard ATP equipment generates the distance to go continuous speed profiles, while the onboard ATO equipment calculates the train control commands to achieve automatic train operation according to the movement authorities from the onboard ATP equipment, the train operation plans, and other information. When the ATO equipment judges that the conditions for the ATO functions are ready, the onboard equipment will switch to the ATO mode, in which the traction, braking, and coasting commands are output by the train to achieve automatic train operation under the conditions of energy-saving optimized control and punctual operation.
Application in telecommunication. As transportation systems become more automated, vehicles have increasing demand on communication and are being equipped with more wireless communication server and sensor. Overall, the maximum data rate of commercial communication system EG4G is still limited to 100 megabits per second for high mobility and default current technology, and not sufficient to handle the terabyte per hour data rate that can be generated in next generation vehicles. Lightweight communication are required to provide various high data rate applications for person and train service. This application needs to be implemented in 5 right scenarios. 1. Train to infrastructure, T2I, HD video and other information in real-time transmission among various infrastructures. 2. Inter-wagon wireless network between wagons. 3. Intra-wagon lines between user equipment and access point of a wagon. 4. Inside station link between access point APS and user equipment. OES in train metal station. 5. Infrastructure to infrastructure A2A HD video and other information in real-time transmission on various infrastructure. Note that where this A2A Ethernet belong to railway communication depend on where this link is managed the railway industry. In most countries, the A2A link is provided by communication network operator, but in some countries, like China, such line is owned and managed by Railway Corporation.
So what is the LSIS CBTC system? Simply, the LSIS CBTC system controls train operation and movement safely and efficiently, utilizing wireless communication technology to calculate the location and speed of the train in real time. By applying a moving block, consecutive trains can maintain a safe braking distance, operating quickly to minimize headway between each other. Essentially, with wireless communication and also the use of the moving block, train intervals can be controlled safely and efficiently. Shall we compare this to the conventional system that we know? The conventional system uses unidirectional transmissions which cannot calculate the exact location of the train on the track, while the CBTC system is able to transmit mass data through radio communication in real time. Hence, the CBTC system can detect exact train locations at all times and has improved safety due to the shorter response frame in emergency situations. Also, compared to the conventional system, in which a train can enter a fixed block only when it has been vacated by the previous train, the CBTC system applies moving block to maintain a much tighter distance between consecutive trains, but still preserves a safe interval, meaning trains can be operated in higher density. In addition, not only is the conventional system improved, but the trackside equipment that detects the location of the trains is simplified, minimizing installation and maintenance costs. With a cockpit no longer required in the CBTC system, the automatic train operation improves efficiency through driverless operation, while the economic efficiency is improved by energy saving. Therefore, a safer, more efficient, and consequently, a more economic LSIS CBTC system is established. But why the L-Trans CX? It is certified at the highest level of safety, Seal 4, in compliance with the relevant IEC standards. With no need for cooling fans and using an innovative cooling system and a compact structure, the self-developed board reduces the maintenance cost of the compact structure. And LSIS L-Trans CX implements a customized system for the operating environment, which is ideal for a user-friendly interface. Consisting of a wayside ATP and onboard ATP ATO, and integrating interlocking and ATS, the LSIS L-Trans CX is ideal for the optimization of train operation control. It implements high-precision equipment while reducing the number of unnecessary tags in place. Diverse radio protocols, which are suited to each customer's needs, are also used.
Pros and cons. Pros: high speed ride HSL as broad number of social and economic benefits, such as short train time, 4 journeys of between on 5 hours, safety, security, comfort and on-time commuting for passengers, energy saving, environmental protection, job creation and encouraging sustainable of renewable energy and land. Cons: the case against high speed rail. High speed rail is too expensive. The required infrastructure in working infrastructure. It's an energy hub. It doesn't go where you want to go. I won't get many people out of cars playing. Into apply in Ecuador. In Ecuador, there is no high-speed rail transport. Study should begin to have the style of transportation in the future. Conclusion: high-velocity railroad in Stein and Stein technology it had big brought into advanced countries like Japan, Spain, France, UK, OS, etc. Due to the high cost for the implementation of high-speed train, a study will be necessary for its implementation at the regional level with whichever country could be involved. Thank you very much for your attention. See you next video. See you soon.